So this is a video going over how to do the whole z-score table A process to turn a value on a normal distribution into a percentile and vice versa. I'm just going to do numbers 6, 7, and 8 from the classwork from the day you learned this, which is the Will Marty Make It Back to the Future worksheet. Okay, so first I think it's worth writing down what you need to have on a free response problem in order to get full credit for these type of problems. So let me make that darker. For full credit, you need to have your original and standardized picture. That's your z-score normal distribution with labels. So it can't just be just a straight picture. It has to have the n parenthesis notation and numbers on it. Okay, and then you also need your z-score formula with work shown, and then you need your answer. Okay, so let's do this problem. So let's do our original picture first. So reminder that the normal distribution on these problems, their mean was 80 and standard deviation was 7.7. So there's 80. And in this particular case, we're looking for 85, which I don't know exactly how far up that is. I'm just going to guesstimate. And we want speeds greater than 85. So the shading is important on these problems. Very important, actually, because you have to keep track of what chunk of it you're interested in. Okay, so there's our first picture. We'll draw our second picture in a second. Here is our z-score formula. Value minus mean over the standard deviation. So in this case, that would be 85 minus 80 or over 7.7, which ends up being 0.65. So we have found out that we are 0.65 standard deviations above the mean, a little more than half of a standard deviation above the mean. So this is a good time to draw your standardized picture now that we have some numbers to plunk on it. So a standardized normal curve is always centered around 0. That's the standardized part. It's shifted and shrunken. So it is centered around 0, and it has a standard deviation of 1. And 0.65, our z-score, is there. So the picture is the same. The visual part of it is the same. What's different is the labels. So on our original graph, we're talking specific speeds, 85 miles an hour. On our standardized graph, we're talking z-scores, 0.65 standard deviations above the mean. Okay, so now is when we break out table A. And this is usually how I show work. I just do an arrow and say table A. And here is table A. Now this is a slightly different version than what you guys have in your textbook or what you downloaded from Canvas. It's just a more detailed version. The decimals go a little farther and the Z goes all the way out to negative 3.9 instead of negative 3.4, but it's the same thing. Okay. So what was I looking up? I was looking up z-score of 0.65. 0.65. So that's on the second page. So here's 0.6. And I follow that over. And here's 5. Follow that down. I end up right there. So 0.74215, or I'll say 0.7422 because that's the same as what you guys have on your sheet. So 0.7422. That's my percentile. So I have found out that 74% of the data is below 85 miles per hour. Now, a thing to keep in mind, what it just gave us is this. So the table is just set up to always give you the percent below a certain amount. And in this case, we want greater than 85 miles an hour. So because we wanted greater than, we need to go 1 minus, or 100% minus 74%, or 1 minus 0.7422, which gives us 0.2578, which is a perfectly fine answer, or you could give it as a percent, 25.78%. Either of those answers is fine. Okay, number 7, how this gets tricky is it's between two speeds. So here's our original graph, and this is really where I think drawing the graph pays off, as it helps you keep track of what is where, and it makes it very visual. So if 80 is in the middle, I don't know, let's just declare 70 to be there, and 85 is 15 above 80, which is a little more than 70 was below 80, so maybe farther out. And we're looking for the chunk in the middle. Okay, oh, and we got to label this 87.7. Okay, so our z-score formula, we do need to write that down. Value minus mean over standard deviation. And what we have is 2 values to find the z-scores of. So we're going to do it for both values, and then we'll talk about how to combine them to get our final answer. So our first one will be 95 minus 80 over 7.7, which gives us 1.95. And if I go look that up on table A, 1.95, 1.95. So we're on the same column as before, but new row right here. 0.9744. So 0.9744. Okay, let's find our other z-score, and then we'll talk about how to combine them. Let's see, what is it? 70 minus 80 over 7.7 gives us a z-score of negative 1.30. We'll look on table A, so negative 1.30. So that's going to be up in the negatives. So negative 1.3, and this will be 0. So 0.0968. 0.0968. Okay, so we have 2 percentiles to work with here. This is a good time to draw your other graph to kind of keep your wits about you as to what's going on. So it's the normal distribution with 0 and 1. And again, the picture looks the same, right? But now we have z-scores we can label it with. Up here is 1.95. And down here is negative 1.30. And we want what's in the middle. Okay, so let's think about this. This guy, the 97%, that is giving us here and everything below. So all the stuff we want, but plus all the stuff we don't want down at the bottom end. Good news is this guy gives us the bottom end. It is all the stuff below negative 1.30. So if we go green minus yellow, it will give us the middle chunk that we need. So 9744 minus 0.0968. So that gives us 0.8776, which is again a perfectly fine answer, or 87.76%. All right. Our last one is different because it is going backwards. They are giving you a percent to start with, and notice the word top. They're giving you a percent above a value. So let's draw our picture. Okay, and I don't know exactly where the cutoff is, but it's going to be somewhere up here, right? This area is 15%, so 0.1500. Now, looking ahead, we're going to have to look up a percentile in table A, and percentiles are everything below a value to the left, not to the right. So we care what the other area is here. So 1 minus 0.1500 is 0.8500. If there's 15% above, then there's 85% below. And this cutoff here, this is what we're looking for. We want to know what's the value on our original graph that is that cutoff. Okay, so I'm going to go look up 0.8500 in table A. And remember, this is a percentage now. This is an area under the curve. It's a percentile. So I need to go look up 0.85 inside the table. I'm not going outside in, I'm going inside out. So, and you're not going to find one that's perfect. You're just going to get as close as you can. So let's see, maybe here is the closest we can get to 85%. So now I'm going to work backwards. I'm going to figure out what's the z-score that goes with it. So 1.04. 1.04. So 1.04 is our z-score. So we can write out our formula. So 1.04 is z. Our value, we don't know what it is. That's our question mark. So I'm going to leave it as x, and we can fill in our other numbers. And then just solve this algebraically. Multiply both sides by 7.7, add 80 to both sides, and you end up with 88 miles per hour. So I never graphed my other graph. But it matches, right? The visual part of it matches, but instead of having actual values, you have z-scores. This was 1.04. Okay, there it is.